Last section of chapter 4, section 4.5, page 303, talks about complex zeros. So here we define the square root of -1 to equal I, and if you square both sides, you get a -1. And that's basically it. All what you have to do, wherever you see a square root with a -1 underneath, put an I, and wherever you see an I squared, replace it by a -1, and a complex number is of the form z equal a plus bi. So you always write it that way, in which this is a real number and this is a real number. So we're going to start on page 311 by, if we want to add those, you treat I like you treat a variable, like x. So when I distribute, that's 6. Positive 3 times -5i is -15i. -4 times 6 is -24. -4 times positive I is -4i. And if you combine the constants, -26 minus 6 is -20. And -15i minus 4i, that's like -15x minus 4x, is -19i. And there's the form that we want. So the idea is fairly simple. The deal is you add two complex numbers, you get them in the form of a plus bi, you multiply them, you divide them, or even if you raise them to powers, they stay like this. So here I need to FOIL 42 minus 28i minus 30i plus 20i squared. So that's basically as much work as I have to do. If I add those, that's -58i plus 20, and the agreement was wherever you see an I squared, you replace it by a -1. And that makes this -20 plus 40, that's 22, minus 58i. And there it is. So it's really straightforward. Not much in there. And if I multiply those, I could do this any way I like. Let me multiply those first. So that is 5i times -42 plus 30i minus 7i plus 5i squared. That is 5i times -42. This will give me a 23i, right? Plus 5 times, and again, I squared we replace by a -1. That is 5i times, and this is -42 minus 5, -47, plus 23i, and if I multiply those, that would be negative, what is that? 5 times 47. 7 times 5 is 35. 23, 235i, plus 5 times 23 is 115i squared. Again, the deal is anywhere we see an I squared, we replace it by a -1. That's the definition. So this is -115 minus 235i. Since I represent a radical, whenever a problem says simplify, you cannot leave your answer with a radical in the denominator. So I'm going to do two problems. Actually, I didn't want to do number 24. I wanted to do an example. Two types of problems. You could see 5 over 3i. If it says simplify, you glance at that, say, okay, what's wrong with this? There's an I in the denominator. So to eliminate, you multiply by the same I. The top will be 5i, the denominator will be 3i squared. And we know what I squared is. That's a negative 1. So that becomes a negative 5/3 I. And if I take number 28, just like we did before, when we rationalize two terms, to ensure that I get rid of a radical in the denominator, I multiply by the conjugate. If you recall, whatever I multiply the bottom with, I multiply the top with a ratio of 1. The denominator is guaranteed to be the first squared minus the second squared. And 8 squared is 64. And we know I squared is negative 1. And as you see, we have just made the denominator radical free, which is the purpose of rationalizing the denominator. So the denominator now is a single number. The top, however, I have to multiply negative 2 plus 7i. A bit of work, not hard, just kind of long. So if I FOIL negative 16 plus 2i plus 56i minus 7i squared, and that is a negative 16 plus 58i, and since this is a negative 1, negative 7 times negative 1 is a positive 7, and that would be a negative 9 plus 58i. There's nothing wrong with this answer, but in the back of the book, they split them up. They make them look exactly like this. So they say that's negative 9 over 63 plus 58 over 63i. And you could reduce that a bit more and say that's negative 1 over 7 plus 58 over 63i. Now, if you get it this far, me and you are very happy. Not a big deal if you don't simplify it. Not in this section. And we get back to our favorite part, find all the zeros. We are not going to graph here because graphing I is not part of this class. Otherwise, I'll be more than happy to show you. We graph that when we get to trigonometry. So just give it a few weeks when we get to our second half of our class. So find all the zeros. I glanced at this. This doesn't match 2 or 3 or 4 terms, but by the previous section, I know how this plays. I look for greatest common factor. I don't see any. So I look at 32 and say the constant is 32. The factors of that are 1 and 32, 2 and 16, 3 doesn't work, 4 and 8, 5 doesn't work, 6 doesn't work, 7, no, 8, 9, 10, 11, nope, that's it. And the constant, the leading term is a 3, the factors are 1 and 3, so I know it's all of these, and all of these divided by 3. The goal is to reduce the fourth degree to a second degree. And second degree I know how to do because we dealt with that in one full section. So plus or minus those. Does 1 work? Let's see how quickly we could figure that out. 32 plus 24 is 56. 59 minus 21 doesn't work. Does negative 1 work? So 1 and negative 1 you could check just by looking with minimal work, which is why I try them without long division or syntactic division. I'll say 32, 43 minus 40. Well, almost that didn't work. Okay, well, brute force it is. Find all the zeros. How about if we test 2? Does 2 work? 3, negative 8, negative 16, 24, and 32. A 3, 6, negative 2, negative 4, negative 20, negative 40, right? Yeah. And that is 16 negative, that's negative 32. What do you know? It worked. Try 2 again. I would always try it, even though it doesn't work often, but I will try that still. I might rearrange this really quick and move things like I did on the last problem. So drop the 3, multiply 3 times 2, that's a 6, that's a 4, that's an 8, that is a negative 12, right? Oops, didn't work. Have my hopes up. How about negative 2? A 3, a negative 6, a negative 8, a 16, a negative 4, and that's a negative 8. That doesn't work. Okay, what's next? 3. 3 is not even part of this, you guys. You shouldn't go there. So, does 4 work? That's the third one. 1, 2, 4. A 3, a 12, a 10, a 40, a 20. That didn't work either. Oh boy, what's going on? How about a negative 4? A 3, a negative 12, a negative 14, a positive 40, 56, 30 some, that's not working. Okay, maybe I'll try. So this is one of those cases. The first 3 didn't work. I'm going to try an 8. If that doesn't work, I'm going to try the fractions. I know you don't like them, but there's a hint for fractions you could try. Let's try the 8. A 3, 24, 22, 116 are going to work. Negative, negative 26, too big. So whenever that's a special case, either a very large number or a fraction, does 1/3 work. The good news, if you end up with integers down here, you're in good shape. Drop the 3. 1/3 of 3 is a 1. Negative 1. When you multiply, you get a decimal. That's not going to work. Try negative 1/3. So I'm trying this number. That is a negative 1. That's a negative 3. If you multiply those, you get a 1, right? Is that right? Negative times a negative is a positive. That gives me negative 19. That doesn't divide evenly. You know that doesn't work. That's the beauty of fractions. How about 2/3? So 2% of the time this happens. 3. 2 times, that's 2. 0. That's a 0. That's negative 20. 3 doesn't divide 20, didn't work. How about a negative 2/3? 3. The 3's cancel out, negative 2. Negative 4, nope. Doesn't divide. Well, this is one of these problems. How about 4/3? 3, 4. A 2 doesn't divide. Try the negatives. So 3, that's a negative 4. That'll be a negative 6. And 3 divides 6 2 times. That'll be a positive 8. That's a negative 12. 3 divides 12 4 times. Negative times positive 16. That works. So I'm going to rearrange this really quick in a minute. Let me move these up here. This way it's all on one line. Okay, so I got it down to 3x squared minus 6x minus 12, right? Equal to 0. Factor a 3 out. That's odd. Yeah, 3 didn't work in the beginning. Okay, minus 4. That means x squared minus 2x equal 4 plus. I like to complete the square. You could use quadratic formula. Take half of the middle number, which is 1, and square it. That's x minus 1 squared equal a 5. Square both sides. X equal 1 plus or minus radical 5. X equal a 2. And x equals negative 4/3. 2/3. That's what it says, find all solutions. You just did. So here, it's not going to always work out as you like. You just got to be careful with that. Okay, due to time constraint, this is the last problem. I want to really do 38, but no time. So here, the factors of a sub 0 are, that's 48, so that's 1 times 48, 2 times 24. 3 divides that, 3 divides 1 time 16, 4 and 24, no, 4 and 14, 4 and 12, okay, I know that. 5 doesn't work, 6 and 8. So 1, 2, 3, 4, 6, 8, 12, 16, 24, and 48. Good news, they're all integers. So does 1 work? Well, let's see. 13, 14 minus, no, not going to work. How about if I put a negative 1 in? F of negative 1, that's 1 plus 2 plus 13 plus 32 minus 48. Maybe 32, 34, 35, 45, 48 minus 48. What do you know? That works. Awesome. So a 1, negative 2, 13, negative 32, and negative 48. You know what? Let me do that right here. Mind as well. And how does that work? I know the remainder is 0. That's a negative 1. That's a negative 3. That's a 3. That's a 16. That's a negative 16. That is negative 48. That's 48. That's a 0. Right? Now, I could factor this by hand. Right? I could factor this by hand, but if it didn't work, 1 didn't work, what's the next number? 2. I'll try 2. $28 didn't work. How about a negative 2? Nope. 40, 52. Almost. Does 3 work? So again, I could factor this by hand because they're 4 terms, and in this case, this is the first problem that worked out that way. There's a 3, there's a 1, there's a 3, there's a 0, there's a 0, there's a 16, there's a 48. Awesome. So what does that mean? That means I'm left with x squared plus 16 equals 0, x squared equal negative 16, x equal plus or minus 4i. Don't forget the negative 1. And don't forget the 3. And there it is. And the homework. And there's your homework.